Okay, we're recording, so Saul, go ahead and get started.
Okay, so we give you the welcome to another takeoff training class, and this time we're going to be talking about parametric steel and Inventor, and this is an extension what we've been talking past week on our engineering meeting. So basically, what we're going to be covering on this training class, we are going to have a model or a steel bar reinforcing created on Inventor, and we're going to follow the entire process to create a part. Number one, it's we're going to analyze the part, and then we're going to be thinking how to model, and finally how to make parametric or programming those parts. So we are going to be jumping between these three stages, and we're going to have a live demo during this presentation. So let's going to start with the number one, how do we analyze a part? So like everything in life, as much more details we have, it's getting more complicated. Of course, the steel bars is only a couple of parameters that we really need to take care about. But as we are going to consider in this training class, those parameters are very important. And one of the things like we are going to be discussing, it's understand exactly what do we want to get and how those bars are going to be working on our process. In my world, or in the steel bar world, uh, what we only are taking care, it's about the thickness of the bar and the width about the bar. This is what we have. So keep in mind those parameters: thickness, width, and obviously the cut size or the long of the part. In these cases, this is 120 inches. And as you can see, we have different conditions, right? Different types. So another thing we are going to be considering is the whole layout. As you can see, according with the thickness, we probably are going to need a hard hole only or a counterbore hole and the hard hole too. So those are a couple parameters that we need to keep in mind when we are creating a steel bar today. So again, we are talking about the width, the thickness, the length or cut size, and the whole layout. That's very important. So with this in mind, I think we can jump directly to there's one more thing we need to consider it. um the orientation, that's very important to orientation. As probably you're aware, when we are extruding our parts in CAD, let's gonna say on the left side we have um a profile, a CAD profile. We're using this plan dimension, the I and C. So when we are extruding the part, that's becoming another fab. We're using now the X as the extrusion length or condition. So that's something important to think about it. How we are gonna make our part. If it's gonna be used on the takeoff, then we have to consider to use this condition, right? Oh, and for that, we are going to see that condition during the process that we are creating our steel bar. So let's going to jump directly to the Inventor, and let's going to start creating a part. Okay, so the Inventor part, what we're going to be creating, that's parametric, exactly what we have right now. And we start creating a new sketch. And as we already discussed, remember, this is the plan that we want to work. So let's gonna start creating a rectangle part. And probably some of you are aware how those Inventor work, but some of you guys are have a lot of knowledge on Inventor. So just be patient with me regarding how do I create this part. Probably have a better options. So here, as we discussed, we are gonna have the width, which is let's gonna say it's 1.5. And when we're working on this side, we're gonna call this, and we're gonna cut thickness. So as you can see, I'm typing the parameter there, thickness, for example. And if I plus equal, and I hit equal, and I could provide the dimension there. So let's gonna say it's 1.5. So that's rectangle now. And this is good because as soon as I have my parameters there, I can change here directly. So I have width and thickness. So let's gonna pretend to use one of our models. So let's gonna make a steel bar like this one here. So let's gonna say it's width 2.5 and 1.5. It's the diameter. So it's only changing here 2.5 and 1.5, and automatically everything in Inventor it's updated. I finish my sketch, and then I can extrude the part, and that's gonna be in the other direction, and I can call it cut size, and then I can say the same, right? I'm gonna call it 120 inches long, and there you go. So I have my steel bar created. I can add just for visual purpose the material. I'm gonna call it steel, and I can add the red oxide. So I can call it red, and there you go. So I have it more only for visual. This is nothing to do with the takeoff or any parameters we're going to be talking. Okay, so let me save my document. I'm going to save it here on presentation. I'm going to call it SB for steel bar. So I have right now 2 parameters right now, or 3 actually. I have width, thickness, and cut size. What else do I need to know? Well, or do I need to incorporate? As we've been discussing, we're gonna need the whole layout according with this. So let me jump to the presentation and I show you something important we need to keep in mind. When we are modeling on Inventor, oh, sorry, I need to go back. There you go. When we are modeling using iLogic, that it's a process that we're gonna be talking about, we need to keep in mind, like, we only can create geometry as we have it. We can share similar parameters. An example, the length, the width, or the height. So we cannot jump from, for example, a width, like a radius, like in this example, right? We can jump from a rectangle to a circle. That's going to make a lot of issues on Inventor. So that's not a good idea to modeling a part. As much more we can carry on the parameters, that's much better. What we can do, well, what it's working on Inventor or iLogic can do, it's, for example, if we set parameters value, we can suppress those and unpress the futures and set the eye properties, right? So as you can see in this example, we have a rectangle or a cube, and then we can add a notch inside, we can add 2 tubes in top, or even we can create another part in above that part. So we can drive those parts with iLogic on Inventor. Okay. Thinking in that, when we have our whole behavior, what we need to think about it is, for example, what is going to happen when I change my thickness here? Well, if I change my thickness, I need to change the contour board, right? If this is 3.25, then I need to reduce my contour board. So, oh, sorry, let me go back. Sorry. So from my perspective, I need to think about where this hole is beginning and how it's going to be the whole behavior regarding the part. What does mean that? Okay, let's going to move to this particular piece. So let's going to add a hole there. And the first thing we want to add, it's here. We go to 3 modeling, we can add a hole. So let's going to say I want to add a hole here. Okay, so if I click on the left side, it's going to provide me the dimension here. So all my steel bars start at 6 inches long, what I have here. So that's my parameter. I already created another parameter starting from 6 from the bottom. And because I want to be centered, I want to use what I already have on my parameters. So if I go to the list of parameters, I can use width and divide it by 2. Oh, there you go. So I have now a completely hole that it's in connection with those parameters. Let's gonna say we want to create something here about the behavior of the hole. So I already added the diameter. That's going to be another parameter. So the only one I need to do is add contour board diameter. There you go. And as you can see, I have only this dimension, 25 inches long, 0.25 inches there. But I need to drive this dimension every time my thickness change. That was the reason, like, I need to create a specific parameter here that it's going to be, or I can call it remaining. What does mean that? Like every time I do, this is the remaining here, 3 1/4. That's a constant every time I have. So if I have a 3/4 steel bar, I'm gonna keep the same consistencies between all my parts. So I need to create these parameters on Inventor, and that's gonna be called as a user parameter. So the only one I need to do is go to add, I'm sorry, it's numeric. So let's gonna call it seed, right? And you can call it where you want. So seed, it's gonna be 3/4 of an inch every time. So going back to my hole, I need to change this. So what's the logic there? Well, the logic is every time I have on my list of parameters, sorry. So list of parameters here, yeah. So every time I have the thickness, sorry, I need to clean the entire part. Okay, so every time I have the thickness, you can reduce. So this dimension here, it's going to be the thickness of the bar minus the other parameter that I already created, that I call it 6. There you go. So what is happening here? Every time, every time I change the thickness of my bar, that counterbar hole is going to be changing, and I can actually prove it right now, making small here. And if I change the thickness here, I was going to say this is 3/4. See, automatically it's updating, and the contour bar, it's gone. So if I go back to my previous, if I increase the dimension there, so as you can see, this is one of the cool things about Inventor. Like we can change things very quickly, and then you have to worry about the rest. As soon as you have a parametric part, you can continue moving. So let me show another thing I can complete. So I need 3 holes here. So the only one I need to do, it's adding more holes here based on the same logic that I already created. And again, I can create the same parameters, right? Following the same dimensions. So width divided by 2. And from here to here, that hole is going to be the cut size divided by 2. So I can use the list of parameters here, and then I can use the cut size divided by 2 to be always on the center. That's going to be. And the final hole, it's here. And this hole is exactly the same logic. This, the start. And from here to here, it's going to be the same logic as we already discussed to be in center line. So width divided by 2. Okay. There you go. So I have 3 holes. Every time I change my part, it's going to be, those holes are going to be adjusted by the logic that I already created. So let me hit save, and there you go. Okay, so I don't know if you have any question, guys, before I move to the next stage.
I do have a question, Saul.
Yes,
Let's say you've got the bar, and the way that you set it up is the width divided by 2 in order to get the center of that hole. But imagine now that your bar is getting wider because the mullion's getting deeper, but the relationship of the hole is not centered because it's got some weird offset on the system now. Would you have to change that parameter to be a specific dimension rather than letting it go to the center line?
Yes, definitely. Yes, I can. I need to go back and then change this logic here, the center line, that rule. But the good thing is, like, if I haven't find any project when we have all the time it's in center line, but it could happen as you mentioned it. But I need to change this in order to follow a different rule. So that's one of the things to keep in mind
Okay.
when we are creating parts. But yes. Any other question, guys? Okay. Very good. So let me move to the next stage then. Let me bring my presentation. Okay. So that's So now that we already create or modeled it or part, I have a bunch of new parameters that I'm going to be using for the process. So that's very important from the very beginning to think exactly what do I want to do. So let me move to the next. Let's going to do something cool what Inventor has. It's called iLogic. What is iLogic? If you click here and add a rule, I'm sorry, no, this is not the one that I was looking. Let me close this one here. There you go. So forms, it's forms. So if you go here and add form, there you go. This is the cool part because forms, it's going to help me to create like an interface about my parameters. And every time I want to change something, the only what I need to do is adding here. For example, I can add a picture. Oops, there you go. And let me see, here's, oh, you can see right now, but there is my form. I can name it still data here. And I can customize my form in order to be more friendly environment. And for example, if I want to add a picture here, I can add like an image from a logo company here. There you go. See, so I have them Walters and Walt. And I can add my parameters here. I have the width, I have the thickness here, and I have the cut size. And because we have this example, that's the only parameters that I'm going to be talking about. And my counterbore diameter here. And actually, I can add one more because we're going to need to change. I can rename those. Let's going to say this is W. This is thickness. This is cut size. Cut size. And this is CB diameter. Oh, there you go. CB diameter. So right now I have, let me save here and save. So right now I have this still here. So every time I click that one, everything is here. And this is more friendly because I can change directly here. So I was gonna say I have 3/4. Oh well, yeah, it could be 3/4. It could be 3 inches. Yeah, and it could be a thickness 3/4. And oh, I'm sorry, I changed the thickness. That's 3/34. 3/4. There you go. Yeah. So I changed the thickness here to 3/4 and the width, and I can change manually now the cut side. I was gonna say this is only 100 inches long. And there you go. So I can changing the entire part just only with a click. Okay, let me move, going back to what I had. It was width, it's 1.5, and thickness is 2 inches thickness and 120. There you go. Okay. Sorry. Thickness. Oh, that's very thick. It's, I was gonna say 2 inches. Where's my example? Oh, I was gonna follow this example. I can create that steel bar. 2.5 and 1.5. Okay, that's width 2.5, and thickness is 1.5 inch. There you go. Yep. Okay. So probably I need to add another parameter because I already create the diameter for the counterbore hole, but not for this hole, the hard hole here. So it's pretty simple. I need to go back to my modeling, and on this here, I need to convert this. I'm sorry. This. I'm gonna call it hard hole dia, and then it's 4375. This is the one that I was calling CB. My bad, CB diameter. There you go. So now I have a parameter that changed the diameter to the counterbore, and I have a parameter that I changed the hard hole at the bottom. Okay, so just tiny changes here. If I go back to the forms and edit the form, I need to change this. This is hard hole. So this is not anymore hard hole, contour bore hole. This is hard hole diameter, hard hole diameter. So you can call it whatever you want, right? So hard hole, and no, that's a good one. And the CB hole diameter. So yeah, as you can see, and I can add as much many parameters that I want. Like I can add, for example, thickness. I can add the part name, the part number, stock number. I can add, for example, the finish and everything that I want, that I want to carry over to my next process. If it's a drawing inventor, or if it's exporting parameters, that's completely you can add those completely here. So this is what we call it, iForms, and you can add as many as you want. And it's pretty cool because, for example, on this example, I already created the steel bar. So every time I open this file, I don't need to worry about to remodel anything. Just open the form, and then just doing the changes that I need. Something cool in Inventor too, it's we have the option to add a rule, and it's kind of more complicated, but for this case, this rule, it's gonna help me to, every time that I open this file, this rule is gonna force to open that form. And this is kind of rules, right? The if, then, and if. So according to what you really need, you can use this. But this is a very simple one. I want to show you the process here. And I'm looking forms and show forms. And now what I'm telling Inventor, it's every time that you run this rule, please open the steel data form. There you go. So if I click save and run, see, now it's working. This is cool because actually on Inventor, I have something called event triggers, which is every time that I have a rule run after open document. So if I grab this here and I put that rule here and I click OK, see what it's happened next time I open my file. So I'm closing and then I open again. So click again. And see what is happening now. So that's very automatically. Every time you open the file, it's showing you the form. So you change everything and then you can continue with the process. So that's what it's covering. Sorry that I'm jumping back. So that's covering the model inventor and the programming inventor. We already discussed exactly how to use rules and how to use forms, which is pretty simple on inventor as soon as you have the logic with the parameters there. So important to remember, so it's the behavior of the part, the use of the parametric parts, and the use of the logic forms and rules. Okay, so far, this is what I was working on it a couple days ago. This is good when you have only a couple of parameters there. So like sunshade bracket, you have more parameters, elbow corners, you have more parameters, you have to change more. I mean, you need to change a lot of stuff there. But so this is a cool or simple example that I want to share with you before I move to the next stage. So any question or any comments you have?
I have a question.
Mm-hmm.
So basically, you create a part and it's already have properties in it, right? You're starting like from the box and you put the holes, you establish the length, whatever it is, like let's say it's a box. And it's already have properties in it, and already these properties will tell you what it is, what do you have on this part, kind of. So if you start changing from the numbers there, you can start typing like some kind of variable. It automatically recognizes that it is now you're creating the parameter, and you need to like, or you need to go, so I kind of missed it, or you need to go like specify this parameter somewhere else, or you can just like by starting typing the name for the parameter, it automatically puts it in the parameter list.
Yeah, it's automatically linked to the parameter release. Yeah, as soon as you have the parameter, you don't have to worry about where is as soon as you link those to the actual form.
So can we just try to like create, like, let's say for this part, for this, I call it a box. It's a box for me with the forms, basically.
Mhm.
So can we like create like in the properties of this box, can we create maybe another parameter, like once again?
Yeah, sure. Yeah, it's only going back to forms.
So can we go back to model, not to forms,
Okay, model.
to
Yes.
model? And just do the properties of the
Properties of the whole.
no, just a part. You have to do like each separate one. See.
Yeah.
So you select the part and you. So you have to specify parameters here, or you're specifying it in the properties?
No, this is the parameters for the part. And as soon as I have it here, good size, I can reproduce the same because it's exactly the same parameters here. See, good size.
So they created automatically once you kind of extruded the part, basically.
Exactly. As soon as I call it.
And you can rename it. Kind of.
Exactly. For well, I can rename it here on the form, but I can rename it directly on the parameters form or list. So I can rename it here wherever I want here. See?
Okay.
Wherever, yeah. So it's only just like following a logic. Okay. Okay.
I was trying to follow along, but it was like my inventor was freaking out and it was very fast.
I'm sorry.
No, I don't think it was intended to follow along.
Yeah, I mean, the point is like when you are creating something on Inventor, add a parameter, remember the name of the logic, and then recycle that every single part you needed. On the forms, we're using those parameters here with thickness, good size. So see, those are exactly the same name Inventor that I already added here from the very beginning of my model.
So from the chat, Katan was asking, can we use the form as an input interface, for example, to generate multiple parts?
Yes, definitely yes. Because for example, let's gonna do an example right now, very quick. Let's gonna say from my presentation, we have this bar here. Let's gonna do this bar here. So I have 2.5 by 1.5, and the good size is where is good size? So let's gonna do it right now. So I have this, and I have the only one I need. It's so width. It's oh, I'm sorry. Width it's 2.5. That's remained is correct, and this is 1.5. And the good size or the span is 120. Okay, that's exactly the same. I want to try another one. I was gonna try this guy here. So this is 2.5 and 1.5. Oh, that's the same.
Can you make the use this one, and just if you don't have a counter bore, like was one of the example, and say counter bore is 0, so it will be just a hole?
Yeah, like this one, for example, I have changed this for a thickness 3/4. So it's 1.5 and 3/4. What I can do is now it's file, save as, and save that specific part this. But this is a waste of time because let me show you the next stage that I've been working. From Revit, from Inventor 2020, we have the ability to export this part directly to a Revit family. So let's gonna say I have this file and I want to create a family with this dimension. So I'm gonna call this steel bar 2.5 by 3/4. So if I go here and I go author building, it's gonna ask me what is the locations. If I wanna, what orientation do I wanna get? So let's gonna assume that's per the file. And if I click here, export building components, I'm gonna call it that bar with the new dimension here on the Revit family. When I call it 2.5 by 3/4 and there you go. So I can keep my form here, and I can create as many as families as I want, changing here this interface or this input interface.
Mhm.
So give me a second. Give me a second. It's working.
Yeah, but Saul, I understand that. But my question was actually, suppose these are the variables, right? Like 5 parameters. So if I like input all those values in certain file like Excel or CSV file or something, and can we import those and generate multiple uh, parts at one shot? That was my question.
It's probably
I can
possible, Kitan, but I don't think like we are there yet, right, Saul?
That's advanced, yeah. But yes, you can do it here on the rules. Let's gonna
Okay.
create a new rule, add a rule. So
Okay.
Excel. So the rule, it's gonna tell me what exactly I want to get. Let's gonna say Excel forms. Hold on, I have here one called it Excel data link. See, so
Yeah,
I can export
perfect.
wherever you want here. You can export to wherever you want. So just selecting the Excel data here, for example, what kind of property you want to get. This is an example only, but
Yeah, no, I have a question, curiosity.
yeah,
That
but
is great.
definitely yes, you can. As soon as you have a value here, you can export, or actually you can import there. So let me see if I can. All the features, parameters. Oh, see, so you can load or you can save as an XML file. See,
Mm.
so it's only following what document you want to save, the path, and exactly. I haven't explored this too much far because I don't know exactly how can we use this, but definitely it's the same as Revit. As you have something here on the parameters, you can do export or import wherever you want, right?
You're just trying to get it on the model right now, right?
Exactly.
Yeah, I'm
Oh,
looking Inventor first time, so I just was curious. Yeah, amazing, and it's a really great tool.
Yeah, Inventor is very satisfying to watch compared with everything else.
yeah, and that's maybe part of this presentation. Like, I don't know, maybe in the future, I know like the company we're exploring using an Inventor. I don't know what happened exactly, because I found a couple of videos when they already have like the framing and
So Ron is working for Seattle, right, guys? And he was telling me that they are actually using Inventor for the pubs.
yeah.
Yes. So what was my interest? In this, if we export the data, like suppose part of the particular part, uh, export the data from the Revit, it is easy. Means we can do that and use as an input to this means through this interface, then it will generate all the part automatically.
Exactly.
Yeah.
For now, my path that I was following, it was very similar what you already are been working. I mean, Catan and all the directors creating families, because let me show you. So this is what I already created right now. See, let me change the realistic. So this is the file that I already exported from Revit. See, it's completely a Revit family that only can be used on Revit 2020. That's one of the roadblocks or issues we having. You can, as those files are only matching with the actual version year. So, but let me show you something beyond this that I've been working on it. So let's gonna say, for example, that I want to add the holes. Oh, I don't want to close this one because it's gonna take me time. So let's gonna go back to my form and let's gonna change again. So see what is gonna happen here. So when I have 1 and a 5, 1, 5, and then there you go. So I was gonna say I have this. This is accurate. So let me export. Let me save this here. What I can do with this part, it's actually even I can create an assembly and adding the fasteners, the bolts, and all those parts, and I can show you exactly how this is working. So let me share. Create a place. Yeah, place from presentations. There you go. So let me. Okay, that's the still part. So I'm still working on Inventor. Oh, my fault. I'm sorry. Okay, my fault. Let me remove those guys. Oh, I have 2 bars. My fault. Still bar, open. Rotate X and place it as ground. Okay, there you go. There you go. So I was gonna say I have this. Something cool on Inventor is actually I can add, my holes are accurate and the dimension there, the diameter is accurate. I can add the fasteners and I can prove that it's accurate according to what Inventor is telling me. The way to prove it, it's on place from content center. If I select heavy hex bolt, which is the one that it's here, there you go. So it's automatically selected by Inventor and it's picking the diameter that I already created. If I can go further, I can go in detail more advanced.
So Inventor has those bolts already in the library?
Yes.
Awesome.
Yes. See, and I can show you. Save still bar. Let me show you. So something Inventor have right now, it's I can add not only the fastener, I can add the washer and I can add the nuts, as you're gonna see here, very quick. So that's a finish. So I select what it's called is on the detail. Oh, my fault. There you go. See? So I have that one added there. So I have the right bolt that it's calling on the shop drawings 3, 8, 16, and 1.5. And I can add follow the part pattern. And there you go. I have the 3 bolts there. And I can apply, hit OK. And there you go. I made a mistake here. Let me go back to fix it because you're gonna notice on the next stage. Edit. Okay. Because this is a steel bar, I need to have a space here. So I'm gonna add a washer there, just only for visual purpose, but you don't need to do it in real life. I'll show you why I'm telling this because, okay, there you go. So I can change very easy anything there. There you go. So this washer, I'm gonna just for, I'll show you why. Let me see, where's the washer? Hex not internal. There you go. So I can, okay. Stability. Okay, yeah, there you go. So now that I have my assembly on Inventor, again, I can repeat the same process. I can move to export part as a Revit family. View, oh, where is, I'm sorry. Okay, so beam content, if I export building, it's gonna ask me to shrink wrap this part because it's kind of heavy, but it's still gonna work. So export building components, and it's gonna ask me again, I'm saving in a Revit family. So let's gonna call it this SB. This is 2.5 by 1.5 steel bar. There you go. So I can save it as a Revit family. And this is the cool part when it starts looking all together. And I'm almost done with this presentation. So just give me a couple seconds. So I can move, for example, to my Revit model here. This is, I was gonna say, for example, I have to include a steel bar here on the actual Revit model. So what I'm gonna do is just very quick and easy. It's just going to the elevation here. Open this elevation just for, this is an example only. Let's gonna say I wanna add a steel bar here to these 3 mullions here. So you go here, you pick the part, I mean, you pick the section view. There you go. So I can go to my steel bar that I was selecting. Is this guy here? 1.5, 1.5? Yes, okay. So this is what is gonna happen now. if I click here, I open the section and I have the actual model here. So the only what I need to do is import my family here. And there you go. See? Oh, I need to adjust a little bit here. Okay. Nothing complicated, just only rotate the part. And I have an actual part that is matching with the actual standard fabrication. And it's on the model. Which is good about this is, for example, Zach, he can start working on this and adding the takeoff parameters the same way as he's working on the sunshade bracket. But see, I have a parametric part completely inserted into the Revit model, and it was pretty easy to do it.
Where is it placing it in relationship with up and down?
Oh yeah, I can adjust that one. Let me move to that.
Would you please select the part, and so it will show all the parameters as an instance parameter?
Well, right now I only have parameters about levels. I need to incorporate those because the when we are exporting, I don't have control about the width. I need to look at it. Maybe it's possible. Yeah.
Oh, okay, that was okay. So yeah. We cannot.
You were asking if it has parameters from the Inventor. I don't think so, right? The only in Inventor.
So far, I don't know, but I think it's possible, and we need to look at it. But at this point, I mean, you guys, for example, are thinking to use parameters, but to me, I don't need those parameters on Inventor because at the same time as you are placing this steel bar, I can continue my path for creating fabs, and I can model it directly from my parameters that I already have on Inventor, right?
Yeah, that is
so
right.
But it's placing it on 0, 0 elevation?
Yes.
I see.
Yes.
So you can adjust it from there. Okay.
Yeah. So,
yeah, but you know what? Actually, the actual process, according to me, it is a reverse process because we are, as a drafter, are deciding the size of the bar, right? And then you are creating the parameter, right? Sorry, part. So I was just wondering if we have like a standard shape and like we can put the parameters here.
You want to have parametric in Revit. I see what you're saying.
Yeah, and then if you can import that family in Inventor, and it can generate the part. So there are two ways, you know, as you said, that either we have to export the values of the parameter, or we have to export the whole part, whichever way it is possible, you know.
Yes. Yeah, that's possible. Yeah. So see, I'm sorry. Go ahead.
Go ahead. No question.
No, I mean, what I have right now, it's the steel bar. It's placing based on the level. So the only one I can do it's if I want to change the relationship with the mullion, I just only add that dimension upside. Yep. And there we go. See, so I move my part. I move my steel bar here. Let's gonna say this is the right place, right? Probably you guys know more exactly where the steel bar here, but this is the Revit model on real part, and only what I need to take care it's about copy that particular mullion, that particular steel bar here, to the next two mullions that I was pretending to do it. One, I'm sorry, supposed to do multiple. Okay, anyways, and there you go.
So in this scenario, currently we have to request the part from you, you know, and then we can incorporate in Revit family. Correct?
Correct. Yeah.
But again, you still have to request the part, Kitan, because we need to have all the takeoff parameters. So it just comes to you like it always comes. So it just.
Yep. Thank you for a great presentation.
Yeah. So yeah, and because right now, for example, Zach, he's creating when you guys having the takeoff program, he needs to incorporate the takeoff parameters according with the process. So you guys, the drafter, are creating the family Revit, but Zach is the one who's adding the takeoff parameters to work with our process. So I think as Jana say, it's probably exactly the same logic here. As soon as you have the Revit here, the part, he can incorporate the takeoff parameters, and you can include the steel bars into your process for the takeoff. There you go. Any other question? So, okay.
Saul, let me ask you, who are the groups that are using Inventor mainly?
So far, only Sherwin, I think so. And me. Does any one of you guys?
We
No.
used it a little bit like 7 years ago, but yeah, we did the Stevens Creek building in Inventor, but it was just a trial. Okay.
Okay.
Yeah, that's a good question because and actually, does any one of you know what exactly happened? Why didn't continue with Inventor? I found these videos here. Me share a couple with you. Like it was very advanced. What I was looking like, for example, frame. I noticed. I don't know who created those, but oh, let me see.
It's in Steve's folder.
Yeah. Let me. This is Inventor. Someone that was working on Inventor, creating frames and see all the extrusion, all the assembly drawings, how to create the frames. So at some point, this company, somebody explored that option, and I don't know what happened. That's what I'm bringing this to you guys. If you know the background about this, why we didn't proceed on this, maybe we can learn from the past or the lessons from the past. But
Maybe we're just very good at it.
Maybe, yeah, maybe. But I mean, at least in my world, using inventory is better to me for precision and holes and time. Probably for you guys, no, I understand that part, but I was looking like they already created an assembly drawing and a frame completely on Inventor. See? Doing the outring and let me see if I can add in the hole. Those are the holes, I think so. Okay, see, but see, it's an entire unit there and on Inventor with the assembly frame option. But
we did it in LAX too, and Tony it was kind of easy. I don't know if it was easy, but I know he was using Inventor files to export it to the machine programming. He was doing it from Inventor files.
yeah,
that was a Sherwin created, created for us.
Was it easy for you to use?
We did it in AutoCAD right now. It's pretty much the same. So it saves Sherwin some time to recreating the entire unit for us.
And it's very parametric, so you can adjust and it will create all the parts you need. Easy adjustment.
Here when it was used, you use that for back checking all the miters and LAA.
Right. That too. So we used it for checking. So we double check all our fabs and then use that to create models for Tony to use.
okay.
Yep, very accurate.
Yeah.
But we didn't use it for what job was it? That was UCSF or whatever the job. We didn't do it. Natural resource, we didn't do it. We just went with the CAD from there.
Okay. Well, yeah. So I'm still looking at it, maybe finding another option, solution, another path to follow on our process, but it's continuous improvement, right? So that's covered my presentation. I don't know if you have any question, any comment.
Sorry, last question. See, the part that we created, right, in the Inventor, can we make a library of that? Or
yeah, I can create a library. Yes.
okay.
Yeah. So far, there is a couple of things that are hanging on the air because we don't have like a process. Like for example, that one where to save all my files, and if someone else needed, how to share that part. So those
No, I mean library in the sense, if we add like as for example, when you click the parts, as for example, the bolt you took it from the library, we can add our part in certain library. That is my
Oh
question.
yeah, you can. Yes, definitely. Yes, you can create a library on the Place Content
Oh.
Center. Yeah, yes, definitely.
Yes, here. Okay.
Mhm.
Thank you.
Here. Okay.
Mhm.
Very good. Any other questions?
Okay, yeah, got it. Thank you.
Okay. So if not, that's it to me. Thank you for coming to this training class and hope to see you soon.
Thank you, Saul.
Thank you, Saul.
Thank you,
Thank you,
Saul, for the
Saul.
presentation.
Thank you, Saul.
Thank you. Great
That's all.
presentation. Thank you so much.
Thanks, Saul.
Thank you.